The given cube is cut into 4 pieces by 2 planes. The first plane is parallel to the face ABCD and passes through the midpoint of edge BG. The second plane passes through the midpoints of AB, AD, HE, and GH. Determine the ratio of the volumes of the smallest and largest of the 4 pieces. So the first thing I have to do is explain this question in detail, and then we'll tackle it. So the first thing we need to illustrate is the diagram. So I'm going to concentrate on this cube and show you how this is being cut. The given cube is cut into 4 pieces by 2 planes. The first plane is parallel to the face ABCD. So that means it is exactly like ABCD, which is right here, ABCD, but it's below ABCD. Where is it? Well, they tell you that. It passes through the midpoint of edge BG. So the midpoint is approximately here. So this is the first cut, like here, all the way across, all right, like that. So that's the first cut, which essentially looks like it cuts the cube in half, with the top half and the bottom half. All right, that's the first cut. The second cut is with a second plane that passes through the midpoints of AB, AD, HE, and GH. So let's draw that, but let's draw that in a different color so you can see what that does. So we're going through the midpoint of AB and AD, so like that. And we're also going through the midpoints of HE and GH, so like that. So hopefully that's drawn pretty accurately. And we're going to slice all the way down. So when you do, you're going to meet the edges like that. If you were to take a side view of this cube, just looking at the side, I'm just looking at the side, and this cut was being made all the way down like this. This cut, that's the first plane, and this is the other plane. This plane, of course, I drew in orange, so I'll draw it in orange over here, like that. There you go. And the other plane I drew in red, so I drew it in red here. This is sort of a side angle. That's how it's being cut into 4 pieces. So it says in the question stem 4 pieces. So we'll label this S, L for small and large, because that's how they label it. And the other 2 are exactly the same. This is also S and this is also L. When you take the first plane that I've drawn in orange and you cut the cube, essentially you sliced it in half, what is the volume now? Well, the volume is length times width times height, correct? Let's say the edge of the cube is 2. All right? Like that. No problem. That's perfectly allowable because in the end they want us to figure out the ratio. So what we call it, it won't matter. So now I want to figure out the volume of not the full cube, but just the half of it. Just that part there. And therefore that volume should be pretty easy to figure out. 2 times 2 times 1. So that's 4. So that means if you're looking at this, that L plus S is equal to 4. All right, the large piece and the small piece are equal to 4. That's very important. That's going to come back later in the question. And before we proceed, let's not forget what we're trying to figure out. Determine the ratio of the volumes of the smallest and largest of the 4 pieces. So they want us to figure out, find S over L, that ratio. Concentrating on the top part, and that top part is going to be my S. So let's see if I can shade it. So this is my top part. That part is my top. This part is my base. And these are my sides. Right there. Okay? That is my shape. That is S. This is the point of the question that is the key, is you have to extend these lines right here. And if you extend these lines right here, like that, it becomes a, so it is a tetrahedron. All right? And we can figure out the volume of that. Volume will be 1/3 times the base times the height, h. All right? So here we go. Do we have all the values that we need? Do we have all the values for base and height? Base we do, right? Because this is the base right here. This is the base of this tetrahedron that I've drawn in blue. And we have this part is 2 and that part is 2. They're just sides of the cube. So the base we do, we have 1/3. The base is a triangle, so it would be 1/2 base times height. So 2 times 2, like that. Okay? The height, however, is something we have to figure out. The height of this tetrahedron is this guy right there. How do we figure that out? Well, the good news is that we have a little bit of that information. If we use similar triangles, we can figure out the rest. From the very top till here, right there, I'm going to call x. So this part here, I'm going to call x. And then from here to here, I know that already, and you should too, it's 1, right? Because that first plane cut it at midpoints, so that's 1. And then similarly, from here to here, I know that is also 1. And I know that from here to here is 2, and that's already labeled. So using similar triangles, x over 1, this x over this 1, is equal to the full height top to bottom, which is x plus 1, over this full base, which is 2. All right? And then if you solve for this, you get 2x is equal to x plus 1, and therefore x is equal to 1. Great. Simple number. So now we have the height. The height is the full from the top all the way to the bottom. And that looks like 1 plus 1, so that's 2. So therefore this becomes 8 over 6. But remember, S is not the total tetrahedron. S is just the part that I highlighted in this shaded red. Remember I was doing that? And then I had to add a top to make it a tetrahedron. So if I can subtract that top, this top here that I drew in, if I can subtract that top from the total that I just calculated, then I can figure out S, and we will be in business. All right, so we are almost done. So now this was total, V total, total volume, and then I just have to figure out now the top volume, which is the part I shaded in green. All right, same formula, 1/3 base times height. 1/3, the base is a triangle. It's 1/2 base times height. It looks like 1 times 1. And we've labeled that in there already. The height we calculated already is 1. So therefore this becomes 1 over 6. So perfect. The volume therefore of S, our S that we are trying to figure out, is the total volume, which is 8 over 6, minus the volume of that top part I shaded in green. And therefore this is 7 over 6. So now let's refresh our memory as to what it is that they wanted. They wanted us to find this, right? S over L. And we also know that L plus S is equal to 4. Okay, so they want S over L. And we also figured out that L plus S is equal to 4. All right, great. So this was S, right? So that means L plus 7 over 6 is equal to 4. So L is equal to 4 minus 7 over 6. So this looks like 24 minus 7, 17 over 6. All right? And therefore, finally, S over L, 7 over 6 over 17 over 6. Invert and multiply. And we'll get 6 over 17. And finally, we have 7 over 17.